Hey everyone, let's take a look at Achieve section 4.5, number 12, dealing with L'Hopital's rule. And in black here, we're taking this limit, the limit as x approaches 7 pi over 2, times the quantity x minus 7 pi over 2, times the tangent of x divided by 7. So what's this limit going to be? Well, notice the first part here is going to approach 0. Obviously, if I plug in directly x is 7 pi over 2, I get 0. So this expression is getting closer and closer to 0 as x gets closer to 7 pi over 2. And then what about this tangent expression here? Well, if I plug in x, 7 pi over 2 divided by 7 is just pi over 2. So this is approaching tangent of pi over 2. And that's a problem, right? I've shown a graph of tangent function over here. As we approach pi over 2, remember we have vertical asymptotes that it's approaching infinity or negative infinity. So the form of this limit is 0 times infinity. That's indeterminate, right? This part's trying to make the limit be 0. This part's trying to make the limit be infinity. So the limit is indeterminate. It could be 0, could be infinity, could be some number in between. Between 0 and infinity or 0 and minus infinity. And so how can we solve this with L'Hopital's rule? This is not L'Hopital rule form. So remember, when I have 0 times infinity form, what I want to do is I want to take this product and rewrite it in a way where it becomes 0 over 0 or infinity or infinity. I could do that by multiplying the tangent portion by the dividing the tangent function by the reciprocal of this function, right? But another way is to just realize, hey, tangent, remember, of theta is 1 over cotangent theta. So I can just rewrite tangent of x over 7 as 1 over cotangent of x over 7. And now this is going to be in L'Hopital rule form. Again, as x approaches 7 pi over 2, the top is going to 0. What's the bottom going to? Cotangent of what? I plug in cotangent of pi over 2, right? Well, cotangent of pi over 2, I've got the graph of cotangent here, is 0, right? And so this is approaching 0 over 0. That's L'Hopital rule form. So that's the goal. When you have 0 times infinity, you want to get it in the form 0 over 0 or infinity or infinity. And I just rewrote this. These are equivalent expressions. And so now we can use L'Hopital's rule. When I use L'Hopital's rule, I put a little L over the equal sign. Okay. Take the derivative of the top function. Well, the derivative of x is 1. The derivative of 7 pi over 2 is 0. So this is just 1. That's easy. And then the derivative of cotangent x over 7 is a chain rule. The derivative of the outer function cotangent, you have to remember, is negative cosecant squared. Right? Negative cosecant squared. If you forget how to find the derivative of all the trig functions, don't forget you can rewrite cotangent x as cosine x divided by sine of x and use the quotient rule to help you derive that if you forget. So it's the derivative of the outer function, negative cosecant squared of x over 7 times the derivative of x over 7. And the derivative of x over 7 is just 1/7. Remember, x over 7 is the same as 1/7 times x. So the derivative is 1/7. So here it is. It becomes negative cosecant squared x over 7. And I brought the negative 1/7 out in front. So that's chain rule down there. All right. Turns out this now is a determinate form. If I plug in directly 7 pi over 2, of course, the 7 pi over 2 divided by 7 becomes pi over 2. I have this expression. And the cosecant of pi over 2, remember, cosecant is 1 over sine, is 1 over sine of pi over 2. Sine of pi over 2 is 1. And this is just 1. Cosecant of pi over 2 is 1. And so this becomes 1 divided by 1, negative 1/7, which is negative 7. So there is the limit of this function. Okay, hope this helps with this example using L'Hopital's rule.